They say the universe is quiet, so quiet in fact that many scientists have called it eerie. Billions of stars, trillions of planets, and yet not a single confirmed message. Not a whisper, not a knock at the cosmic door. But what if we've been looking in the wrong direction? What if, instead of signals, something physical has been drifting through space? Not a radio wave, not a beacon, but an object, quiet, cold, watching. And what if that object has just entered our solar system? On July 1st, 2025, astronomers detected something strange. An object racing through space faster than anything we've seen from another star entered our system on a hyperbolic orbit. It came from nowhere, its trajectory not bound to our sun. That alone would be newsworthy. It was only the third confirmed interstellar object in history, after Oumuamua in 2017 and 2I Borisov in 2019. But this one, named 3IATLAS, wasn't just another visitor, it had peculiarities. Its path is retrograde, meaning it's moving opposite the planets. Its entry angle was eerily aligned with the solar system's plane, almost as if it were purposefully aimed, and its speed unprecedented. Initial observations showed it wasn't just passing by, it was behaving more like a probe than a rock. And then came the twist. Astronomers began noticing signs of comet-like behavior, a growing coma, the faint glow of gas and dust. But even as scientists confirmed it was likely a natural outlet, one voice refused to let the mystery go. That voice belongs to Harvard astrophysicist Avi Loeb. To many, he's a respected academic. To others, a provocateur. But ever since he controversially suggested that the 2017 object Oumuamua might have been alien tech, he's become the unofficial spokesman of academic rebellion in the search for extraterrestrial intelligence. And now he's back with a new hypothesis. He doesn't claim 3IATLAS is an alien probe, but he refuses to rule it out. In fact, he's urging scientists and the public to consider all possibilities, including the unsettling one. Because here's the kicker, a recently published but not peer-reviewed paper has reignited the debate, suggesting 3IATLAS could potentially be a hostile alien reconnaissance object, releasing undetectable mini-probes as it flies past Earth. Think of it as a cosmic surveillance drone, hiding in plain sight, disguised as ice and rock. The idea sounds like science fiction, but the mere fact that scientists, even fringe ones, are openly discussing it, that's enough to rattle the astrophysical status quo. So, is this all hype? Another UFO-fueled fantasy, or is there something genuinely strange about 3IATLAS? Something that warrants our attention. In this episode, we're diving into the deep end of the cosmic pool. The science, the controversy, the politics, and the chilling implications of what it would mean if an interstellar object wasn't a comet at all, but something watching, measuring, and perhaps even reporting. Because whether 3IATLAS is just an icy rock from another star or something far more deliberate, one thing is certain, space just got a lot less empty. On July 1, 2025, the ATLAS Asteroid Terrestrial Impact Last Alert System Survey Telescope in South Africa picked up something strange. It looked like a comet, faint and distant, and initially there was nothing too remarkable about it. But once scientists began plotting its trajectory, everything changed. This wasn't an object looping around the sun like the thousands of comets catalogued before it. This one was inbound on a hyperbolic trajectory. That means it wasn't gravitationally bound to our solar system. It was moving too fast to have originated from here and would not be returning. It was, in technical terms, an interstellar object, only the third ever recorded. The first was 1 Oumuamua in 2017, and the second was 2 Oumuamua Borisov in 2019. Now came 3IATLAS, and like the others, it arrived not with fanfare, but with quiet, data-rich mystery. Immediately, astronomers all over the world turned their instruments toward the incoming traveler. At first, the object displayed behavior consistent with a comet. It began forming a coma, the cloud-like halo of vaporizing gases that surround a comet's nucleus as it approaches the sun. Spectroscopic analysis revealed the presence of water, carbon dioxide, nickel, and even traces of hydrogen cyanide, chemicals commonly found in comets. But as more observations came in, the anomalies began to surface. The object's trajectory wasn't just hyperbolic, it was also retrograde, meaning it was moving in the opposite direction to the planet's orbits around the sun. This is highly unusual. Even for an interstellar object, that kind of orbit is rare. Most things in the galaxy, stars, planets, clouds of dust, tend to rotate in roughly the same direction due to the angular momentum of the galaxy itself. So a retrograde orbit immediately suggested that 3IATLAS had a very different origin, or had undergone an unusual dynamical evolution. More striking still was its plane of approach. Unlike the randomly inclined orbits of typical long-period comets from the Oort cloud, 3IATLAS was nearly aligned with the ecliptic, the flat plane in which most planets orbit the sun. This raised a few eyebrows. It's not proof of anything artificial, but for those willing to entertain less conventional theories, such precise alignment could suggest intentionality. The chances of a purely random interstellar object entering our solar system from the galactic void along such a perfect plane are small, but not zero. To skeptical scientists, it was still well within the bounds of cosmic coincidence, but to others, it started to feel like a pattern. Then came the speed. As 3IATLAS barreled toward the sun, its velocity was measured at over 110 kilometers per second relative to the sun, making it not only the fastest interstellar object ever detected, but one of the fastest natural bodies to ever pass through the solar system. This kind of speed cannot be generated by solar gravity alone. It had to come in with that velocity from the galactic neighborhood, hinting at a powerful gravitational sling from some distant star system or event. Its origin point, however, remains unclear. Astronomers have tried tracing its path back through space, but galactic drift, gravitational perturbations, and observational limitations have made that all but impossible. It could have come from almost anywhere. Despite these oddities, most astronomers still lean toward a natural explanation. They point out that comets can be strange, especially ones that come from outside our solar system. With no prior context for how interstellar comets should behave, the scientific community is cautious about drawing conclusions. But one thing is certain: 3IATLAS is a unique celestial object. It's not just another rock, it's a message, if not in words, then in its trajectory, its chemistry, its speed. A message that the universe is still full of surprises, and sometimes those surprises come hurtling toward us from the stars. While most scientists looked at 3IATLAS with fascination and academic caution, there was one voice in the astrophysics community who immediately challenged the consensus, and that voice was none other than Professor Avi Loeb of Harvard University. To those who follow space science and astronomy, Loeb is a familiar name, often spoken with a mix of admiration, skepticism, and sometimes outright dismissal. His reputation for questioning mainstream assumptions had already placed him at the center of a heated debate in 2017, when he proposed that the now famous interstellar object Oumuamua might be a defunct alien probe or light sail rather than a mere rock or icy remnant from another solar system. That idea, which he defended with a mix of mathematical modeling and rhetorical provocation, earned him headlines around the world and plenty of criticism from fellow scientists. But while most of the academic community moved on from Oumuamua, Avi Loeb didn't. Instead, he doubled down. He launched the Galileo Project, a privately funded scientific initiative aimed at investigating unidentified aerial phenomena, UAPs, and searching for potential technological artifacts from extraterrestrial civilizations. So when 3IATLAS appeared on the scene in 2025, it was almost inevitable that Loeb would weigh in. And weigh in he did. Within weeks of 3IATLAS's discovery, Loeb published an article on his Medium blog titled "Should We Be Happier If 3IATLAS is a Comet?" A seemingly innocent question that carried a provocative subtext. In the article, he acknowledged the evidence that supported a cometary interpretation, outgassing, coma formation, spectroscopic readings, but also emphasized the unusual features that could hint at something more artificial or engineered. He pointed to the object's speed, its retrograde orbit, and its near alignment with the solar system's ecliptic as statistically improbable coincidences. He wasn't saying it was an alien probe, but he was adamant that science should remain open to that possibility, especially given how little we still understand about interstellar visitors. Loeb's stance is grounded in a broader philosophical argument about the scientific method. He frequently argues that the burden of proof should not rest solely on the shoulders of those entertaining extraordinary ideas, but also on those who dismiss them without fully exploring the data. In his view, assuming that every unexplained cosmic object must be natural is itself a kind of dogma, a bias that limits discovery. The sky is not classified, Loeb is fond of saying. He believes the scientific community has grown too cautious, too afraid of ridicule, and too invested in protecting its own orthodoxy. For him, 3IATLAS represents not just a scientific anomaly, but an opportunity, a second chance to seriously explore the hypothesis that intelligent life might exist elsewhere and might even be sending objects through space. Of course, not everyone agrees. Many of his colleagues have criticized him for conflating speculation with science and for using the media to promote ideas that haven't been rigorously peer-reviewed. Some accuse him of eroding public trust in astronomy by flirting too closely with science fiction, but Loeb remains unfazed. He insists that the public has a right to know what's being considered, and that transparency, even when controversial, is better than silence. To him, the worst-case scenario is not being wrong. It's ignoring the possibility of being right. And in the case of 3IATLAS, he's once again chosen to ask the question most others won't. What if this object isn't just a comet? What if it's a visitor? As if the reappearance of Avi Loeb in the conversation surrounding 3IATLAS weren't already controversial enough, what came next launched the debate into the stratosphere of speculation and scientific discomfort. In early August 2025, a preprint appeared on the open-access server Arxiv.org, a platform frequently used by physicists and astronomers to share research prior to formal peer review. The title was striking in its ambiguity. Implications of interstellar object 3IATLAS for hypothetical extraterrestrial reconnaissance models, but buried beneath the academic phrasing was a proposal bold enough to send ripples through the scientific and public spheres alike. The paper argued that it was not unreasonable, however improbable, to consider the possibility that 3IATLAS was not simply a passive interstellar rock, but an active surveillance platform, possibly of artificial origin, with the potential to deploy miniaturized probes or drones for planetary reconnaissance. The paper, written by a trio of astrophysicists and data scientists from institutions in Europe and Asia, walked a delicate line between theoretical modeling and outright speculation. The authors were careful not to claim that 3IATLAS was an alien probe, but rather that its trajectory, velocity, and structural behavior, especially its anomalous acceleration patterns near perihelion, could not yet be fully explained by cometary physics alone. More alarmingly, they pointed out that a small dip in reflectivity, followed by a sharp spike in thermal emissions, could theoretically be consistent with the ejection of small high-velocity fragments, what they termed non-gravitational anomalous ejecta. While mainstream scientists interpreted this as likely cometary outbursts of volatile gases or dust jets, the authors floated another possibility, a controlled or semi-controlled release of autonomous microscale devices. Not weapons necessarily, not invasion, but reconnaissance drones silently dispatched into our solar system, programmed to observe, collect data, and potentially transmit information back to a mothership that is merely passing through. This hypothesis, while sounding like the script of a Christopher Nolan film, was presented with enough scientific veneer to command attention and draw swift condemnation. Critics attacked the paper's speculative framing, calling it irresponsible, sensationalist, and unhelpful to the public understanding of science. Some accused the authors of cloaking science fiction in mathematical jargon. Others were more charitable, acknowledging that while the paper raised interesting philosophical questions, it did little to move the scientific conversation forward without empirical data. NASA, the European Space Agency, and several major observatories issued quiet statements reaffirming their interpretation of 3IATLAS as a natural interstellar comet, pointing to its well-documented coma, volatile profile, and spectroscopic data consistent with known solar system comets. Despite the pushback, the paper ignited a media firestorm. News outlets ran sensational headlines about alien drones, silent invaders, and interstellar spy rocks. Talk shows debated the implications. Podcasts speculated on secret government programs. Twitter, now called X, exploded with hashtags like the ATLAS probe and alien comet. Meanwhile, public interest surged in Loeb's Galileo project, which pledged to analyze any anomalous signatures detected by ground-based or space-based telescopes. Whether intended or not, the paper had cracked open a cultural conversation. For the first time in decades, a segment of the public and scientific world was openly engaging with the possibility that we might not be alone, and that if alien intelligence exists, it may not arrive in a flashing spaceship or a radio signal, but in silence, shrouded in ice and dust. In the weeks that followed, the authors of the paper clarified that their aim was not to spread fear, but to expand the realm of permissible scientific inquiry. They argued that avoiding hypotheses simply because they sound extraordinary is a failure of imagination and curiosity. After all, they noted, humanity itself is beginning to explore robotic space exploration at interstellar scales. Is it so inconceivable that someone or something else got there first? The arrival of 3IATLAS in 2025 did not occur in a vacuum, neither literally nor figuratively. To understand the magnitude of the public fascination and scientific controversy it sparked, we must look back to the two earlier interstellar objects that passed through our solar system, Oumuamua and 3I Borisov. These were not just astronomical curiosities, they were paradigm-shifting events that challenged long-standing beliefs about our cosmic neighborhood and forced the scientific community to confront the sobering reality that our solar system is not as isolated as once thought. And for many, they were the opening acts in a much larger drama, one whose latest chapter is now being written with 3IATLAS. In late October 2017, astronomers at the Pan-STARRS 1 telescope in Hawaii detected a fast-moving object zipping across the sky. It was quickly designated 1A Oumuamua, a name that in Hawaiian roughly translates to scout or messenger from afar, arriving first. That poetic label would prove eerily appropriate. Unlike any known asteroid or comet, Oumuamua had a hyperbolic trajectory, meaning it came from outside the solar system and would never return. But it wasn't just its origin that baffled scientists. It was its behavior. Oumuamua exhibited no visible coma, no tail, and no sign of outgassing, yet it accelerated as it moved away from the sun, as if being pushed by something. Most comets experience some level of acceleration due to jets of gas released by solar heating, but Oumuamua lacked any such indicators. Its elongated, cigar-like shape and strange tumbling motion added to the mystery. The official explanation settled on a kind of exotic hydrogen iceberg or extremely porous dust pancake. But these interpretations were met with skepticism due to the extreme physical properties they required. This gap in understanding is where Avi Loeb entered the picture. In a now famous 2018 paper, he proposed that Oumuamua could be artificial, a light sail perhaps powered by radiation pressure sent intentionally or accidentally by an alien civilization. The backlash was immediate. Many scientists considered the hypothesis reckless, even irresponsible, but others were intrigued. Loeb's theory, whether one agreed with it or not, accomplished something rare. It made the public care deeply about a rock from another star system. It also made the scientific community uncomfortable in a way that sometimes precedes breakthroughs. The debate over Oumuamua continues to this day, with no definitive answer and no similar object ever detected until now. Then, in 2019, came 3I Borisov. Unlike Oumuamua, Borisov looked and behaved exactly like a comet. It had a coma, a tail, and a consistent spectroscopic signature. It was the smoking gun that proved Oumuamua wasn't a fluke. Interstellar visitors were real, and perhaps even common. But Borisov was less mysterious and consequently less headline-worthy. It confirmed a theory but didn't challenge one. Still, its discovery established a new branch of astronomy, interstellar object studies. Telescopes began scanning the skies with renewed focus. Software was upgraded to flag objects with hyperbolic orbits. The astronomical world braced for the next one. That next one turned out to be 3IATLAS, and it landed in a world vastly more prepared and infinitely more speculative than the one that greeted its predecessors. The lessons of Oumuamua taught us that nature may have surprises beyond our current models. The lessons of Borisov taught us that interstellar comets can look just like solar system ones. But 3IATLAS exists in the liminal space between those two extremes. It behaves mostly like a comet, but not entirely. It follows a trajectory that could be coincidental, but just might not be. And it has appeared at a time when public belief in extraterrestrial life is at a cultural and political tipping point. The scientific groundwork laid by Oumuamua and Borisov ensures that 3IATLAS is being studied more intensely and more skeptically than any object of its kind in history. In the weeks following the discovery of 3IATLAS, international space agencies found themselves in an increasingly familiar position, forced to walk a tightrope between scientific conservatism and public curiosity, between staying grounded in empirical observation and addressing the soaring speculations that inevitably come with cosmic anomalies. NASA, ESA, JAXA, and other observatories around the world scrambled to prioritize observations of the object, adjusting telescope schedules, pushing spectroscopic analyses to the forefront. and quietly increasing coordination behind closed doors. On paper, their public statements remained calm, measured, and appropriately cautious. NASA, in particular, was swift to release a fact sheet explaining that 3IATLAS was consistent with an interstellar comet, exhibiting spectral characteristics typical of solar system icy bodies and showing no confirmed evidence of artificial origin. Yet, for those reading between the lines, the language seemed carefully chosen, not entirely dismissive of fringe theories, but not welcoming them either. The official stance was clear: this is science, not science fiction. Behind the scenes, however, a different kind of urgency was unfolding. According to reports leaked through independent science bloggers and insiders within the planetary defense community, there was a noticeable uptick in real-time monitoring operations surrounding the object. Not because 3IATLAS posed any threat, its trajectory ensured a distant pass from Earth, but because it represented an opportunity to study interstellar material up close. An opportunity that might not return for decades, and whether publicly acknowledged or not, an opportunity to confirm or rule out even the most unlikely hypotheses. NASA's Jet Propulsion Laboratory, JPL, reportedly initiated a cross-departmental working group to centralize data from optical, infrared, and radar observations. Although officially described as a standard protocol for transient objects of interest, some interpreted the move as indicative of a heightened awareness that 3IATLAS could, under the most extreme interpretations, be more than just a rock. The European Space Agency, ESA, took a similar approach, albeit with less media attention. Their network of ground-based telescopes, particularly those in Chile and the Canary Islands, collected long-exposure images of 3IATLAS to monitor its coma and track micro-variations in its albedo and outgassing. These measurements were shared with international partners under the IAU's Minor Planet Center, which has served as the global hub for interstellar object tracking since the days of Oumuamua. Internally, ESA maintained its reputation for methodical skepticism. A leaked internal memo, however, emphasized the object's rare alignment with the ecliptic plane and encouraged teams to log any anomalous photometric behavior not attributable to standard cometary activity. At the same time, smaller agencies and private institutions began to seize the moment. Telescopes from Israel, South Korea, and even amateur observatories in Arizona and New Zealand reported on 3IATLAS, contributing data to the global science community. The Galileo project, founded by Avi Loeb, issued a public call for volunteers and astronomers to contribute high-resolution imagery and machine learning analyses. While Loeb himself doubled down on his interpretation that we should leave all possibilities on the table, the majority of scientific institutions issued quiet rebukes, not direct criticisms, but gentle reminders that extraordinary claims require extraordinary evidence. What all these responses made clear, however, was that the scientific world was no longer able to dismiss public engagement with interstellar phenomena. The cultural climate has changed. The era of dry academic detachment from cosmic anomalies is fading. Space agencies are realizing that people no longer accept a wave of the hand and a half-page summary. They want details. They want transparency. And above all, they want to know whether that faint smudge of light in the telescope's eye might be something looking back. The moment the public caught wind of 3IATLAS, the object escaped the control of astronomers and scientists and became something far larger, a cultural phenomenon. Within days of the first wave of news articles mentioning the mysterious interstellar object, often using headlines like "Alien Comet" or "Mysterious Visitor from the Stars," the internet exploded. Hashtags like Jane, Atlas, Visitor, Alien Probe, and Star Messenger began trending across X, formerly Twitter. Reddit's Are UFOs community doubled in size, and YouTube became saturated with videos analyzing orbital simulations, grainy telescope footage, and speculative interviews with physicists, conspiracy theorists, and amateur astronomers. Even TikTok, with its bite-sized attention span, joined the frenzy, spawning a trend where creators imagined first contact scenarios or performed elaborate skits about receiving messages from the comet. It was clear this wasn't just a rock from another star system. It was a character in humanity's ongoing narrative about its place in the cosmos. What made the public reaction to 3IATLAS unique was how layered it became. On one end of the spectrum, there were those who approached it with the wonder and awe it deserved. Science communicators like Neil deGrasse Tyson and Bill Nye appeared on late-night shows and podcasts, calmly explaining the nature of interstellar comets while emphasizing the scientific significance of such an object. They used words like rare, valuable, and mysterious without drifting into sensationalism. Their tone was measured, but their enthusiasm was real. On the other end of the spectrum, however, were the conspiracy forums, where 3IATLAS was quickly absorbed into broader narratives involving government cover-ups, secret extraterrestrial treaties, and predictive programming in Hollywood. Some online threads claimed the object was following a controlled deceleration pattern and that it had released undetectable reconnaissance units. Others compared it to depictions in ancient religious texts or supposed coded messages in pyramids and medieval art. Netflix and other streaming platforms wasted no time. Within 3 weeks of the object's discovery, Netflix announced a fast-tracked docuseries titled Interstellar, The Visitor, featuring dramatized reenactments, interviews with astronomers, and animated CGI reconstructions of what 3IATLAS's journey might have looked like across light years. The trailer racked up millions of views in days. Similarly, Amazon Prime optioned a fiction series loosely based on the idea of a stealth alien probe seeding data-collecting nanomachines across solar systems. Even Hollywood, ever opportunistic, jumped into development meetings for new scripts referencing the object. What had begun as a quiet alert in a telescope logbook had morphed into full-fledged global entertainment. Religious groups also weighed in. Some evangelical Christian circles interpreted 3IATLAS as a divine sign, likening it to the Star of Bethlehem or warning of apocalyptic messages to be decoded. Prominent televangelists began referencing it in sermons. Islamic scholars debated whether such a cosmic visitor fit into eschatological frameworks found in the Quran. Meanwhile, in India, spiritual gurus described it as a possible cosmic messenger and held meditation sessions intended to connect energetically with the intelligence behind the object, if any existed. In a time when people increasingly hunger for meaning in a chaotic world, 3IATLAS had provided a cosmic Rorschach test. Everyone saw in it what they needed most: hope, fear, wonder, or proof. Yet, amid all the interpretations, jokes, and digital noise, one thing was undeniably clear: the world was watching. The public fascination was no longer confined to lunar eclipses or Mars rover selfies. Interstellar objects had become modern myths, and their meanings extended beyond the scientific data they carried. 3IATLAS had revealed a truth as deep as the object was distant, that when something arrives from beyond the stars, it doesn't just pass through our skies, it passes through our consciousness. As 3IATLAS slowly fades into the distance, exiting the solar system as quietly and enigmatically as it arrived, the object leaves behind more than a data trail in the databases of observatories. It leaves behind an imprint on the human imagination, whether it is ultimately recorded in scientific literature as an unusual interstellar comet or an unresolved anomaly, its passage through our cosmic neighborhood has already reshaped conversations that span science, society, and even spirituality. It has reignited the latent human yearning to look outward and ask not only what is out there, but who might be looking back, and more urgently, whether we are ready for that encounter. For scientists, 3IATLAS has served as both a treasure trove and a test. It challenged observational protocols, provoked theoretical boundaries, and forced open doors to hypotheses many would rather have kept shut. The very fact that it garnered this level of attention alongside serious speculation about artificial origin marks a turning point. No longer is the alien hypothesis strictly the domain of science fiction or fringe theorists. It is increasingly a scientific question, albeit one with little data and profound consequences. While most researchers will ultimately conclude that 3IATLAS is natural, they must now grapple with the broader epistemological tension between skepticism and imagination. They are reminded that dismissing possibilities without examination is no more scientific than blindly believing them. The object may prove to be nothing more than a frozen relic of another solar system, but it has already expanded the framework within which we interpret such relics. For the public, 3IATLAS became something else entirely: a story, a symbol, and a mirror. It revealed how deeply the question of extraterrestrial life lives within the human psyche. The outpouring of attention it received across social media platforms, streaming services, podcasts, and even religious discourse is a testament to our species' instinctive need to find meaning in the cosmos. Some saw a probe, others saw a sign. Many simply saw a mystery worthy of contemplation, and in a world overwhelmed by political division, climate anxiety, and economic uncertainty, here was a celestial visitor that united billions in a single act of collective wonder. Whether it was through a TikTok video imagining alien contact, or a backyard telescope tracking the comet's trajectory, 3IATLAS offered something rare: the feeling that we are part of something bigger than ourselves. Perhaps most importantly, the saga of 3IATLAS underscores the convergence of technology, storytelling, and existential inquiry in our modern era. We now live in a world where a distant object, tiny, cold, and ancient, can spark debates about extraterrestrial ethics, influence Hollywood productions, and inspire late-night conversations between people who have never looked through a telescope. Our telescopes have become extensions of our curiosity. Our data, our doubts, and our dreams are now interlinked. And that, in many ways, is the legacy of 3IATLAS. Not just that it passed by, but that it made us pause, look up, and reflect. We may never know what 3IATLAS really was. It may disappear into interstellar darkness, never to return, never to reveal its secrets. But its greatest impact may lie not in what it was, but in what it asked of us. In it challenged our understanding of science, sparked our wildest imagination, and reminded us that, in the vast silence of space, even the briefest whisper can change everything. In the end, the true journey wasn't the one taken by the object, it was the one it inspired within us.